Why do you look at me?
Why do you start a video off by saying, why do you look at me?
Oh,
You're watching this video. Yeah, oh yeah, you're being recorded now.
Don't look at me.
This is going directly on YouTube after this class. Let's talk about the Pythagorean Theorem. By the way, it's Pythagorean, not Pythagorean. What do you know about the Pythagorean Theorem? Do you know it? A squared plus B squared equals C squared, but what does that mean? What are A, B, and C? And please don't just say variables.
The sides of a triangle.
The sides of a triangle, right? Almost. This relates to us the sides of a right triangle. So if I have a right triangle here, and it has sides A, B, and C, but you gotta make sure you put these in the right spot, right? The side, this longest side here, is your C, and the shorter sides would be your A and your B. Now C has a special name. Do you remember what his special name is? This guy is the hypotenuse. Remember something about the hypotenuse. This guy's always, it's always the longest side, and it will always be opposite the right angle. It's always the side that's opposite the right angle. See, it's directly across from that right angle. Okay. Now what about the shorter sides here? What are these guys called? Did someone say, what'd you say?
They're called legs, right?
Legs, yes they are. Most people forget what these guys are called. These guys are called legs. So when we talk about, word problems, or someone's talking about legs of a right triangle or the hypotenuse, you know where they go. You know what part they're talking about. Okay. Well, there's something really neat that we have with Pythagorean Theorem. We can talk about solutions for the Pythagorean Theorem. Well, just suppose I gave you this example right here. If I told you that I have this, and I wanted to find this length right here, how could I find that x? I can use the formula that's given to us. That's a squared plus b squared equals c squared. But you've got to make sure that you put these guys in the right spot. The only guy that really matters is the hypotenuse, because it doesn't matter if you call this a and you call this b, or if your buddy calls this a and that b. It doesn't matter. What matters is that we all agree that 5 is the hypotenuse, because it's the side that is directly across from the right angle, right? So I'm going to plug into this formula. I have 3 squared plus x squared equals 5 squared. Is this something that you can solve?
Yeah.
I sure hope so. When I look at this, I get 9 plus x squared equals 25. If I move the 9 to the other side, then I have what? X squared equals 16. So then what does x equal? X equals 4. Now if we think about this equation right here, I see that I have an exponent of 2, so I kind of expect to have 2 answers, right? Well, let me show you what that would really look like and why I can kind of ignore that for this particular problem. If I look at this guy, and I had moved that 16 over so that we have x squared minus 16 equals 0. If I gave you this equation, how would you solve it?
Add the 16.
I wouldn't add the 16. That'd be going right back where I was. But in terms of the zero factor theorem, I would factor this guy. He's the difference of squares, x plus 4, x minus 4, right? But when I solve this equation, I get x equals negative 4, or x equals positive 4. But I've got a problem with these answers. What's wrong here? Why can I not have negatives? I can have negatives in the other problems that I've done. Why can I not have a negative here? What is x representing? X does not represent the squared number. X represents the length of a side of a triangle. So since I know that I'm talking about length, I know that my variable must be representing what? A positive number. So this guy right here, this doesn't make sense for this problem. So that's why this guy is the answer that I have right here. So x equals 4. You guys with me on that? Now, there are some really neat things that we have here with the Pythagorean theorem. And they are called Pythagorean Triples. Pythagorean Triples are super awesome. These are things that you really should have memorized. And what these guys are, these are integer solutions to the theorem. When I say integer solutions, remember I'm talking about positive, in this case, just whole numbers that are going to work here. So, for example, 3, 4, 5 is a Pythagorean triple. Okay, and, why is that? Well, because 3 squared plus 4 squared equals 5 squared. If you don't believe me, work it out. In fact, we just did, didn't we? We just came from that example. Because up here we found out that x is equal to 4, and these are nice whole numbers. 3, 4, the hypotenuse is 5. That satisfies the Pythagorean theorem. Okay? Some other common ones that you may see. 5, 12, 13. 7, 24, 25. 8, 15, 17. And 9, 40, 41. All of these guys are Pythagorean triples. Now, there are an infinite number of Pythagorean triples. There are some that, the numbers get really, really huge. But what we need to understand about these is that these are all relatively prime numbers. There's no common factor for all of these guys. What you can do with this, though, is that you can create other triples that would satisfy the Pythagorean theorem by multiplying or dividing everything by the same number. For example, this 3, 4, 5, what if I multiplied everything here times 2? I would get 6, 8, and 10. That would also satisfy the Pythagorean theorem. Or what if I took this guy right here and I multiplied everything times 10? So if I had 80, 150, 170, that would also satisfy the Pythagorean theorem. I could divide by the same number, so I could have fractions here. But as long as it's based off of this Pythagorean triple, then it's going to be very nice. Now, not everything is going to be nice and pretty like these numbers are. In fact, when you go on further, you're going to see that sometimes the solution with the Pythagorean theorem, you get weird square roots. But that's okay, you just learn to deal with it.